expansion for the Taylor series. Then in general, this is what we're going to use. So depending on the order given, you truncate that transformation. Are you getting it? So assuming if it is first order, then everything here becomes error. Are you getting it? So you differentiate to the first term. If it's second order, you differentiate to the second term. Do you understand? Yes. If it's third order, you differentiate. So you differentiate to the number of terms what given. So we're going to solve the same question which we tried today, okay, using the Taylor series words technique. I was saying the difference in this technique here is you'll be given the order of expansion, which is n. Here we've been given n equals to 4. It means you have to find the derivative to the fourth order or for the fourth derivative. Okay. Yeah, so what you do is you're going to differentiate this function. Okay, we have t minus y over 2. So in the first equation, the first derivative has already been stated here. The question is already the first derivative. So which is t over 2 minus y over 2. And then you have to differentiate that, which gives us, let me be sure this is recording. Okay, so have the squared y over the s squared will give us, when we differentiate t over 2 with respect to t, you get 1 over 2. And then you differentiate y over 2 with respect to dt, you get y prime over 2. Okay, and we know that y prime is t minus y over 2. Okay, so you substitute the whole of t minus y over 2 into the numerator here. Okay, so this will give us, let me use the annotator. So you're going to bring the whole of t minus y over 2 in place of y prime here. Okay, so then the expansion gives us 1 over 2, which is this term. Then the 1 over 2 here, the denominator comes here. And then this t over 2 is what you have over here. Okay. Very well. So in the next place, you have to find the third derivative. The third derivative here, when we differentiate 1 over 2, we get 0. Okay. Better still, let me expand from here. When you differentiate this, you're going to get 0. When you differentiate this, you still have 1 over 2 outside. Or if you like, you can expand it. If you expand it, you get what? Negative t over 4. Okay. Plus what? Plus this times this will give us y over 4. Okay. Then you differentiate. When we differentiate, we'll get negative 1. Okay. Very well. So in the next place, you have to find the third derivative. The third derivative here, when we differentiate 1 over 2, we get 0. Okay. Better still, let me expand from here. When you differentiate this, you're going to get 0. When you differentiate this, you still have 1 over 2 outside. Or if you like, you can expand it. If you expand it, you get what? Negative t over 4. Okay. Plus what? Plus this times this will give us y over 4. Okay. Then you differentiate. When we differentiate, we'll get negative 1 over 4. Okay. Plus 1 over 4 y prime, like you're having here. So negative 1 over 4 plus y over y prime over 4. okay? And like we know y prime is the same as what you have here, okay? So place the here. So you share this. So 1 by 8 is 2 minus y prime over 2. So that is for the fourth order. The next thing we need is to estimate the general function. We have square y equal to the order. So we put values are the given values. First is we're going to substitute the given values x naught, y naught. We said at x equal to 0, y is equal to 1. So we substitute it into this function here. Okay, so dy dx at 0, 1 will give us what? That is 0 over 2. Let me bring the annotator. You put 0 here, you put 1 here, you get 0 over 2 minus 1 over 2, which will give us half. Okay, then the same way, when you come here, this is the function. So you put 0 here, you put 1 in here, and then you estimate. When we estimate, you get 3 over 4. Then the same way as 0, 1, you put 0 in here, you have 1 in here. Once we do this calculation, we'll get negative 3 over 8. And then finally, for this function, you put 1, 0, 1 in here. When you do the calculation, you get 3 over 16. So that gives us y prime, y prime prime, y prime prime prime, and then y raised to the power iv. Okay. So next, let's see how to get your y1. Let me clear all of this. So clear, right? So to get your y1, your expansion is going to be what? y1 is equals to y naught plus h dy dx plus a squared 2 over 2 factorial the squared y dx squared plus h raised to the power 4 the 4 over 4 factorial d raised to the power 4 over x raised to the power 4. Okay, so that will give us, we're told that y1 was y naught equals to at x equals 0 was 1. Okay, your step size, let me go back a bit, let's just refer to that. So your step size is 0.1, your y naught is 1, and then x naught is 0. So let's come here, y naught is 1, your step size is 0.1, your dy dx, we calculated that to be what? Negative 1 over 2 here. Okay. Then we have for the next term, that is h is 0.1 squared over 2 factorial. Okay, so 0.1 squared over 2 factorial. Then the squared y, the x squared, previously we had 3 over 4. Then this is h again, h cubed over 3 factorial. Then the cube y over what? Dx square will give us negative 3 over 8. And then h, this is h raised to the power 4 factorial, and then the derivative to the 4th order. Okay, so once you combine all of this, you do this estimation, you're going to get 0.9536882813. Okay. Okay. Now, let me take questions from you before we proceed. If there is any question, let me have that. Yeah, any question? Any question? Is there any question somebody want to ask?
So we are still trying to is this storing into the memory?
Okay. So whilst it's going to the memory, let me just refresh your mind. The first thing is you have to find the derivatives to the number of order you are given. Okay. Then after you finish finding the derivative, you will substitute the initial value conditions.
Okay, sir.
Get the value of the derivative at those points. Okay. And when you are done, you come and put those values into the general equation to get your y1. Okay. Can you come back with your question? Your network was a bit bad. It's off. Okay. Okay, we'll take it. Any other question before we move on? Lizzie, do you have a question?
No.
Okay. Okay, so let's move on. So which means that once we do all this, we get our y1, which is the first iteration. Okay, good. Then you have to continue, because in the question we're told to find y at x equals to 0.4. What we've just calculated is y at x equals to what? 0.1. That's the first iteration. So you have to keep going till your x is what? 0.4. Okay. So in the next iteration, you have to go back to your original equations. This is the dy dx. Yeah, so in the next iteration, you don't find the derivatives again. Those are the equations you'll be using throughout. So all you need to do is to go and substitute your y1 value, because now your y1 is 0.953. And then your t is now 0.1. It is increased with the step size. So you go and substitute it into your y prime, y prime prime, y prime prime prime, and y iv. Okay. And then once you do the substitution, just substitute. So this time it's going to be, you put 0.1 here. So we have 0.1 over 2, and then 0.9953 8, and the rest. You put it into the function to get your answer. Okay. Then you do same for this, do same for this equation, do same for this. Once you've obtained these answers here, 1, 2, 3, 4, then you substitute into the general equation. Okay, so you then go and substitute into the general equation here, this equation, okay, to give you y2. Are we clear? Are we clear on that step?
Yes. Yes, sir.
Yes. So once you've obtained y2, you come back again and re-estimate with a new y2 value. So in the new calculation, you use a new y2 value, okay, whilst your t is going to be 0.2, okay? Then after you found y2 value, you come back to this same slide again, this same step, this time using the y3 and then 0.3, okay? And then repeat the process for the last time with your y4 and 0.4. Okay. And then, so let me repeat that step again. So I said, finally, you come back, use your y4 and 0.4. Okay, for the estimations. Okay. And that will be the final value, because in the question, we're told to find the expansion to y at what? T equals to 0.4. So once your t is 0.4, you end off with the estimation at that point. Are we clear on that? Hello, class. Okay, Patrick. Patrick, are you with us? Okay. I'm sure we've all written down the equation. Have we captured the equations? Hello, class. You've been unmuted. Have you captured the equation?
Yes, sir.
Yes, sir.
Okay, so we can continue then.
Yeah.
Okay. Yeah, so like I said from the beginning, okay, there are higher order Runge methods available. Okay, however, and what we also have to know is the higher order methods are more accurate, okay, but require more calculations, so it takes more time. Okay? So programming this will even take a longer time to give you your simulations or to give you your results, okay? And then the last point we have here is a fourth order, that's RK4 method. It's a good choice. It offers both good accuracy with a reasonable calculation effort. So it is fast and the margin of accuracy is also very high. Okay, that is why we're looking at it in class. Okay, so let's take an example. We are asked to find y to 0.4, okay? Given that y prime is equals to t minus y over 2 using Runge Kutta to the fourth order, okay? And we've been given initial value condition y at 0 is equals to 1, okay? And the step size is 0.1, okay? So we're going to calculate a number of iterations till we get to what? X equals to what? Sorry, t equals to 0.4. Okay, so we'll move 0.1 from 0 to 0.1 to 0.2 to 0.3 to 0.4. Okay, good. Now, how do we go about this? Okay, it's very simple. Like I said, all you need to do is first, you've been given the question, divide dt is equals to t minus y over 2. Given initial conditions. So in solving, what you need to do first is to find your y1, y2, y3, y4, okay? So in the Runge Kutta method, you have to find y1, y2, y3, y4. Using the equations I asked you to note, okay? Good, so y1 is what? F at what? T naught, Y naught. Okay, that's the equations we took earlier. This is it. So F1 is okay. Like I said, I wanted the confusion, us not to have any confusion. So instead of Y1, I'm making it F1, F2, F3, F4. So F1, okay, is F at T naught, Y naught. Then, of course, the F at T naught, Y naught is just the differential equation evaluated at the initial condition, okay? So that is going to be T is 0. So we have this to be 0 here. T is 0, so we bring the value 0 in here, okay? And then Y is also 0, so 1 comes in place here. So we have 0, okay, minus 1 over 2. And that will give us negative 1 over 2, okay? Then you do the same thing for the next point, which is F2. F2 is going to be what? T naught plus H over 2, okay? Y plus H over 2 F1, okay? So you just substitute the value. So we know this is 0. The step size is also what? Is 0.1, okay? Step size is 0.1. But let me mention this. The whole of this term is now your X. Take note of that. So the whole of T naught plus H over 2 becomes your what? Your X or your T in this case. This function is a function of T. So when you are substituting into the differential function f of what? F of what? T, okay? When you are putting in the function, this t has been replaced with the whole of what you have here. T naught, okay, plus what? Plus h over 2. You get it? So in that case, instead of writing t minus y, this is the whole of t. So it becomes what? T, which is 0, plus the step size h, which is 0.1 over 2. Then the minus comes in. The minus in the formula here comes. So minus. So then the minus comes in. So we have minus. So minus what? Now this whole thing here replaces your y in the equation. Okay. So minus y naught. Y naught we know it's equal to 1. So you put it, you substitute it here. Plus h is 0.1. So this is h here. Okay. Over 2. 0.1 over 2 here. Then your f1. F1 is what you calculated up here. This is it. So this is f1. So it means you always go and pick the previous value and substitute into what? To find your next value, which is f2. Okay. So we bring this value here. And then once we calculate, we do the calculation, we should get 37 over 80. Okay. Yeah. So let me take you a little back. Some of you were in late a bit. So let me take you a bit back. This is for this is the expansion for the third order. Can you see, for third order, you only calculate F1, F2, F3. And then the general expansion 2 is different here. Can you see it?
Yes, sir.
Yeah, so each order has its own expansion and general term. Okay, but like we were saying, the fourth order gives us a reasonable level of, a high level of accuracy and a reasonable number of calculations. So our concentration for today is on the fourth order. Are you okay?
Yes, sir.
Good. Is everybody okay with the first computation before I move on to the next one? Okay, I guess so. So let's go to the next calculation. That will be F3. So F3, like I said, you need a value of F2, okay? So in F3, this whole term is going to replace T in the equation. So that will be 0 plus 0.1 over 2 will replace this T in this function, okay? Then this whole term is going to replace Y. So Y naught we know is 1, okay? Plus what? H is 0.1 over 2. And then F2, we've calculated F2 to be what? 37 over what? Negative 37 over 80. This is it, okay? So we substitute in the equation. So this is T, and then this whole thing is Y, okay? Then over 2. And then once you do the calculation, you end up getting negative 14483 over 3200. Okay. Then what next? We have to find F4 as well. So in F4 is the same thing, but take note, in F4 it's only the step size, not H over 2, okay? And then this is also what? H times F, it's not H over 2, okay? Good. Now, once you substitute, that's going to be X naught is 0, H is 0.1, Y naught is 1, H is 0.1, F3 is negative 148 over 3200. So we substitute, this whole thing here is T, okay? And then this whole one here is what? Is your Y. So it's T minus Y over 2. So when you substitute and calculate, you end up getting this value. okay? Then once we have our F1, F2, F3, F4, we'll now come and put it in the general equation, okay? In the general equation, that will give us which is yi plus 1 is equals to yi plus h over 6, okay? F1, F2, F3, F4. Now, if you look at it carefully, this Runge Kutta method is more or less a weighted averaging technique, okay? If you add the coefficients here, this is 1. So 1 plus 2 plus 2 plus 1 will give you 6. So over here you have h over 6. So we are finding, it's more like finding the weights, okay? The weights of the function. So one edge point here, another edge point here. Then you have 2 here. So you have to average it over 6. Now, take also notes that this function I've given to you, okay, if you look in other texts, sometimes instead of writing the general equation like this, okay, they will prefer to write a general equation I plus 1, okay, is equals to yi, okay, plus h, plus, then the expansion terms come, which is f1 plus the rest, okay, f1 plus the remaining terms, okay, that is 2f2 blah 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 over 6 here, okay, but the h will come at this point. They will come and put the h here, okay, the h will come here. In either case, if the h comes here, then indirectly it's here, okay. So when you substitute it, it will come as HF, which means when you substitute again, it will come out as your factor here, which is H, okay? So don't get confused. This formula is very complete. In case you meet the ones with the H here to find, but don't forget that you should not bring H here once you use an expansion which already has H in front of it. Are we clear on that? Good. If you have a question, you can raise up your hand. Okay, so on that note, when you substitute all of these values we've just estimated, that will give us, so at n equals to what? At n equals to 0, okay, we'll get y1 is equals to what? Is equals to y0, okay, plus what? Plus h, which is 0.1, okay, over 6, into brackets, we have f1, which is negative 1 over 2. Anyway, why not is also known, okay? This value is known to be 1, okay? Plus what? Plus 2 times of what? Negative 37 over 80, okay, plus what? 2 times, yeah. So I want you to expand that in your books and then calculate it for me, okay? Replace this one with 1. It is 1. So do the calculation for me in your books and give me the answer.
Okay, summer class, so do the calculation for me. We're expanding f, this using the general term. So that is yi plus h over 6, f1 plus 2f2 plus 2f3 plus f4, okay? f1 is negative 1 over 2, f2 is negative 37 over 80, f3 is 1483 over 3, 200, and then f4 is calculated here, okay? So you have to put all together and then give me the answer. Simplify everything for me. Okay, are you done? Summer class, are you done?
I'm still on it, sir.
Okay.
Hello, what did you get?
0.9536882813.
Yeah, I think you are correct. You are perfectly correct. I don't have it here, but I remember the answer. It's 0.9 something. Okay, you are perfectly correct. Okay, So once you are done with the first iteration,
Yes, sir.
Where is it? I think this material is truncated. Okay. So once you are done with this first step, it means you have your Y1, okay? So then in the next calculation, you're going to use your Y1, okay? Y1 is now 0.95. Can you mention it again? 0.95, Stephen?
36
36
88
88
8.
8828.
Yes, 13.
Okay, 228. Okay, so and now your t value, okay, is moving toward 0.1 because we've moved from the first point, which is 0. We are now moving to 0.1. Okay, so what you're going to do is you come and substitute this value back into these 4 equations you have here. Okay, you just come and substitute all those values back into those 4 equations. So for F1 is going to be what? It's going to be F evaluated at T1, comma, Y1, okay? Which is going to be equal to what? T1 is 0.1, okay? Minus the value you have here for Y1, which is 0.995, 36, etc. Okay, over what? 2. Okay, that is how you get your F1. Then once you are done, you come and use the F1, okay, in here, but all values will be based on your T1 and then your Y1 value here. So this, in this new calculation, is going to be T1 plus F of T1. Let me clean this. Good. So it's going to be F of T1, okay, plus H over 2, then Y1, okay, plus H over 2 F1, which you would have calculated here. This is your F1, okay? This is F1 here. Good. Then once you calculate it, the new value you get, you come and use it in estimating your F3. So when you come here, this is also T1, this will be Y1, this will be T1, sorry, this should be T. So this will also be T1, this will be Y1, okay? Good. Then once you are done with this step, the next thing is to repeat the iteration. You just come and plug your new values you obtain, all 4 values, into this function. Because now we are at n equals to what? N equals to 1. So if n equals to 1, then it means we are looking for what? Y2, okay? That's 1 plus 1 here. So Y2 will be equal to what? Will be equal to Y1, okay, plus your step size, which is what? 0.1. Step size remains constant, okay? Over 6. Then into brackets, the new F1, F2, F3, F4 value you calculated, you put them here. Add everything and then estimate this 2. That will give you Y2. Once you get Y2, you go and use Y2 value. You use Y2, okay, the new value you get, and then your T2 has now moved toward 0. What?
Right.
T2 is now 0. What?
3.
Are you sure? We just finished with 0.1.
Oh, 0.2, sorry.
0.2, yes. Okay, so now we are 0.2.
0.2, sir. Sorry.
Yeah, 0.2, good. So when you come here, same estimation. Okay. So here you're going to use T2, Y2, okay? Y2, here 2 will be T2, Y2. This 2 will be T2. This will also be Y2, okay? Then you do the same substitutions again, right? Once you finish with all the substitution and obtain your F1, F2, F3, F4, right? Then we come and find Y3. That is at n equals to what? And n equals to 3. That's the third iteration. We have Y3 is equals to what? Is equals to the Y2. The Y2 you had previously, okay, plus your step size, which is 0.1 over 6. Okay, then you substitute the new values you've calculated using the point Y2 and T2. Okay, you substitute it. Once you are done, you get the new values you get will be Y3 and then what? T3. Okay, which is what? 0. What? 0.3. Okay, and in the question we're asked to find y at what? 0.3. Okay, y at 0.3. So that is when you're going to end with your computation. Let me clear this and write it well. So the question we're asked to find y at 0.3. So you have to estimate till you get to what? Y at 0.3, where t is equal to 0.3. That is when you end with your calculation. Are we clear on that? Good. I'm unmuting you for your questions.
Okay, so summer class, let me take any question from you. Let me take questions from you, summer class.